To another episode. In this episode, we'll be making an anti-theft alarm. Join me as we go on this. I'll be making use of a 47 microfarad capacitor, a 47K resistor, 10K resistor, 1K resistor, BC547, PIR sensor to sense the movement, and a buzzer to notify the owner or to notify the owner of the system if there is any buzz passing. I'm picking up my board now. This is my IC socket. Let's locate the wire board. Okay, I've done that successfully. I need to sew. So let's do this. Okay, so it's coming on. Okay, so the iron is on. So the iron first. Let follows. And let on the other side. So we have done that successfully. Let's check our board. So there'll be 47K. 47K, let's bend. From pin 7. 1, 2, then the third one, resistor. These are 47 UF capacitor. Same thing. Poles in 6, 1, 2. Then the third one, the longest charge, which is our positive. But before that, let's bend 90 degrees. Okay, should be because that one is going inward. So let's put this here. Let's tape it. Let's begin our socket that serves as the supply. Then let us be O on pin 8 towards our left. Let's leave a O, and I'm leaving a O. So I'm having this kind of setup. So this is what we have. Okay. Let me see, something to 5. before that, let's bring our 78 to 5, because we are trying to look at a dual and hybrid system where we can use both 2 volt and 5 volt with it. So bring our 78 to 5. Yes. So we have our 78 to 5 now. So the 78 to 5 will be mounting 78 to 5 on with the pin 8. So to my left, I'll be counting 2 holes, 1, 2, and on the third one, I'll be putting in my 78 to 5. Okay, let me just bend it. Enter my solder. So this. So let's do it. Okay. So I'm trying to make sure that nothing is jamming on the board. So let's cut. Let me just bend it a little bit upward. So we have that. So I'll be placing my supply pin 2 holes away from the, okay, I'll place my supply pin 3 holes away from the 78 to 5. So let's count 1, 2, 3. First, then let follows. Our capacitor. Okay, let's do this. Pin 2. So for pin 2 to. So right now I'll be counting 2 holes away. 1, 2. Then on the third one, I'll be dropping my resistor 2 holes away from pin 2. Okay, in there. So pin 2 to ground, sorry, pin 2 the other side of pin 4. So let's bring in our transistor. transistor, this BC547. So let's look for a suitable for it. 547. The transistor BC547, we're going to pin 2. The first leg, which is the collector, we're going to pin 2. There should be a hole between pin 2 and the next one. So this hole right here will be vacant. We won't be putting anything inside. So we extend the second leg to the one next to the vacant one, and the third leg enters the one that follows. So this is what I'm doing. So for the view, so let's bring in our okay. Let's put down. We need to be very careful so we don't jam. Okay. So we are good to go. Let's slide this up. Just 82. A little bit of shaking. Now. Okay. This is nice. So let's bring in our 1K resistor. So let's bend it. This time I'll be showing you how to use my hand to bend this. Give it straight 90 degree. Okay. So let's bend this one forward a little, this transistor forward a little, so we can mount our capacitor. So we'll be mounting the resistor at the back. Okay, let's remove the. Let's try and cut. Don't be what problem. So the resistor at the back of the transistor. The first of the resistor will be going to the middle pin of the transistor, which is the base, while the second leg extend out and out. So the distance between the first leg and the last leg is, we'll be using 4 holes. There's a reason. I'll explain later on. Let's give you the reason now. The reason is because the resistor will be the one bringing signal to the transistor. So we need to give it more space so it won't interfere with the 72.5. So let's okay. Let's sort for. This one is going to the middle. Let's cut. The reason why we are using transistor to bring in signal is because the sensor, which is the PRL sensor we'll be using, is giving out a positive signal, and for us to trigger our 555 timer, we need the negative signal. So once the PRL sensor sends 5 volts or any voltage, any positive voltage, when it senses movement, the transistor gets turned on and send negative, which is ground, from the emitter to the collector, and the collector is connected to pin 2. So it's sending negative from emitter to collector, which will help us trigger the 5-5 timer. Okay. Continue. So we've done that. We have, let's bring in our sockets. This will be our output socket for the buzzer, any other component or indicator, depending on the one you choose. You can decide to use light, but in my own space I would love to use buzzer. So let's come pin 5, which is from this manner: pin 1, pin 2, pin 3, pin 4, pin 5. So pin 5 on that track, let's move 2 space, 2 holes to the right, 1, 2. Then on the third one, which is the third hole, let's move 2. Okay, let's move a single hole towards me, 1, 2. So we're placing the socket in the outlined, which is 2 holes from the socket, IC socket, then a single hole from this point. So let's go. 2 holes from the IC socket, a single hole. Sudan is hot, very hot right now. So I need to be very careful when soldering. Okay. So we'll be bringing out a signal from pin 3. So let's just check the distance between pin 3. Okay. So let's strip it off gently. You can see what we have. Let's measure from pin 3 to the last leg of the socket. Let's bend. So to the last leg of the signal socket. Okay. So just we just use this one to straighten it a little. Then slide. From pin 3. Okay. So from pin 3, you will directly. Okay, so we'll be taking it from pin 3, the first hole from pin 3 to the last hole, which is a hole away from that. It seems our. Okay, let me bring it out. It's not fitting in. I need to make it a little. Pin 3, a hole pin 3, then 2 holes from our signal socket. So just press a little. So So we are doing well. So far, this is what we have. Okay, so far this is what we have. We're going to add some pinouts later on, but let's do the routing first, then add the pinouts. Let's do the connection first. Pin 8 is going to pin 4. So let's do that. Pin 4, let's drop down gently, one hole at a time. Pin 4, which is the reset button, since we are not using any reset button for now, is a monostable application. We'll be taking the pin 4, which is the reset button, to positive, and our pin 8 already has positive on it. Turn off to the positive wheel and wasting lead, just repeat to pin 8 gently. Okay, so let's bring it down. Okay, yeah, good. So we have successfully connected our pin 8 of the IC to pin 4. Now let's take pin 1 to ground. The middle leg of the 7825 is ground. So we'll be taking pin 1 to the middle leg of the 7825. Pin 1 to the middle leg. Pin 1 of our IC to the middle leg of the 7825. So one of our IC sockets is connected to 7205. Let's do the same for the last leg of the 7225, which is the supply pin to the board. This is the one that will convert the 12 volts to 5 volts and maybe to. So I'll be taking it to the pin 8 of the IC. So that's my positive. So let's do that. Okay, we are good. This is good. Okay, so we have successfully done that. Our socket. Let's connect the socket of our supply, our 12 volt supply. Let's connect it to 7225. The middle one, the one inward, going to the middle leg of the 7225. Let's do so. Let's do so. it right now. I'm soldering. Oh. Yeah, just jammed both legs, so I'm trying to separate it. So let's do the same thing for the last leg. Now we'll be going to the third leg to the left, 30 to 5. So let's do the same. So then it's getting very hot. Okay, we are done. We are done with this. We have our 12 socket. This is it. So our 12 socket is connected to the 70 to 5. The first pin here is connected to the last pin here. The one inward is connected to the middle one. So we need to extend our ground invitation to our transistor. So let's extend the ground to the first pin of our transistor. Let's do so. Okay, so I'll be doing so in this manner. Okay. Here we have that. So our negative rail has first pin, which is the emitter of our transistor. Let's connect our pin 2 to the transistor and the resistor. They are on the same rail. So where is that? Okay, pin 2. So we need to do this inwards. One O at a time. Switch off your soldering iron. Okay, we are good with that. Jumper. I just finished bringing the pin 2 of the IC socket to the third pin of our transistor and the first pin of our resistor. So I'll be taking this jumper to pin 3 of our IC socket. Let's do so. So this time we need to be very, very careful because that place is already occupied with lead, so we don't jam anything. Let's do so gently. Okay, done that. So the second leg of our jumper, we'll be taking that to the output pin, which is the signal pin. You want going to any of our devices, either your bulb, or anything of your choice. So let's do so. Okay, we've done that. This is a win for everyone. This is nice. So we need to take the negative to the other leg of our signal pin to join the negative rail. Doing that now. The other leg of our signal pin. Okay. Other leg of our signal pin to join the negative rail. Okay. Let's do so. Okay. Okay, so let's take it. Okay, let's go a bit lower. So I'm trying to bring out the negative rail. Okay. Okay. So let's join it together. At a time. We've done that. Okay. So our resistor here needs to come to the positive rail, which is we have a positive rail on before our IC socket. So it will be better we just take it to. We extend the invite to the resistor. Let's do so. Let's just bring it a little bit upward. Okay, we are good to go. Let's see what we have. That's gone. Our transistor has gone to pin 2. So let's deal with the guys up here. Let's deal with the components up here. We need to connect them. Let's connect them together. So our pin 6 and pin 7 will join together. The IC, pin 6 and pin 7 of the IC will join together. Let's move it up. So pin okay, the resistor pin, the first pin of the resistor by the let's do so. Okay. 7k resistor to positive. Let's do so for our let's connect our pin 6 to pin 7 together. Done that. Okay, let's connect the first leg of the capacitor to the second leg of the resistor, then bring it to pin 7. Okay. Everything is fine with us. Let's bring the second leg of the capacitor. Second leg of the capacitor. Let's bring the second capacitor. This is our ground rail. We've done that. I'm just trying to reduce the lead. Okay, that is nice. Okay, let's check our board again and see in positive 12 volts is going to 47k resistor. 47k resistor is connected to our 47 microfarad capacitor. Then from there it's coming to the negative rail, which is connected to the signal socket for our output. Our 10k has gone to pin 4 to tap it positive. The other leg of our 10k has gone to pin 2. The collector of our transistor has gone to collector of our transistor have gone to pin 2. Okay. The base of our transistor has gone to 1k. The emitter has gone to the negative rail to tap negative. And our 7825, the output is connected to pin 8 of the IC socket pin. The middle of the 7825 is connected to negative, and the other leg is connected to the 12 volts. So let's bring out our pins. Let's bring out the pins now. So a pin for the signal, bringing a pin for the signal, a pin for the ground, which is the negative, our PIR sensor, and average. Let's check first. Okay, let me just do it once it's time. The other leg for the ground, just put it here. Okay, just put it here. I should bring another leg for positive where I can attach positive. Take of the pin out. Let me bring it to. Okay, I'll be putting it right next to the 10k resistor. So I have. Okay. I'll be positive rail over there. So let's just see. Rail. Okay, this one going to the. This is going to the signal. Okay, this comes to the positive rail. Oh, so that one was very up by now. Oh, be very careful when soldering so we don't burn our board. Okay, we are almost there, almost on the finish line. Okay, we'll be pressing this and what? Yeah, I'm rolling this. Let me stretch out so I can start cutting. So be very careful when you are cutting. You don't cut towards the board and have nothing to use. Yes. Okay, so I'm done my cutting. Can you see? Let me separate. So I need to separate. And everything. I need to keep separating. Let me keep separating. The reason why we are separating is to make sure that nothing is bridging on the board. That's the reason we are separating. You need to separate, make sure that nothing is bridging on the board. So I'm separating each line tracks. Okay. Almost there. Let's take a second look. So nothing is bridging together. One of the reasons why we are using 72.5 on this our sensor needs 5 volts to operate. Anything more than 5 volts can destroy the sensor. So it is pegged to 5 volts. So it is advisable to use 72.5 to make sure that your voltage are regulated to 5 volts. So let's start the test. So my multimeter is on 20 volts DC. The reason why I'm putting it on 20 volts is because it is higher 12 volt DC that I'll be measuring. Okay. So let me get my power source. This one can come in a little. Power source. I'll be connecting my power source. I'll be putting it on the board. This is my supply socket. Let me put it. Multimeter to check. So I'll be running the test on this board now. My positive probe, the red one, will go to pin 8 of the IC socket. my negative probe will go to pin 1 of the IC socket. Then let me switch it on. So I'm having 5 volts, which is good from a 12 volt supply. So I was able to achieve 5 volts from 12 volt supply because of this 725. It's the one regulating from 12 volt to 5 volts. And the reason why we are using 5 volts in this circuit most is because of this sensor. This sensor works 5 volts alone. So that's one of the reasons we need to be very, very conscious with the voltage levels. So, okay. As well. Okay. I think it's fine. It's okay. I think it's off. So, like I used to say, always disconnect your, even though you have switched off the switch, but don't forget to disconnect your supply. So if you remove this cap, it is labeled. The first leg is the voltage supply, which is 5 volts. So let's close it back gently. So I've already plugged in my socket to it. Then here are my wires. So the first one is positive. To be sure. Okay. Yes. Oh, I see that very hot by now. So okay. So let me take my positive with this allocated pin. Get our pin out, the one we soldered right next to our 10K resistor from pin 2. That's my positive. Okay, I'm good with that. Negative. Let me do this. Let me drop it on it. So the negative is coming to this pin out over here. Then the signal pin coming to the pin right next to the 1K resistor, the signal pin. Okay, so we are good. Okay. So let's plug in our, where's my buzzer? Okay, let's plug in our 72.5, the brain of the O system. Let's tilt it a little to give us a 90-degree angle. Let me do this same at the other side. So we have a 90-degree angle. The arc, we go to the same arc on the board, the same direction. So let's put it on it. Any mistake in reversing this IC can lead to damaging it. So we are there already. This is good. Let's plug in our buzzer. So I'll be connecting my supply. So right now I'll be switching it on. So that's it. Let's give the system a little time to rest. Very sensing some stuff. So as I'm doing that, let me check the voltage. So put your negative probe on your 72.5 to see the voltage coming out of the. Okay. To see the voltage coming out of the signal. So let's check it together and confirm this. Okay, let me just. Can you see? Okay, so it needs time to boot and everything. So after that, so can we see we're having 1.6 volts at the signal. If any obstacle, like if any motion should occur, it will bring out a voltage, a positive voltage. Then after the whole timing, which was set on the IC, it goes back to 0. If I should go again, it will burst. So if you are using light now, whenever you move, the lights will come on. But right now we are using buzzer, so whenever anybody crosses our perimeter, we can know. Okay. This sensor it captures wide angles as well. So whenever it senses any movement, any motion, it returns a positive voltage. And don't forget, it needs to boot when we put it on first. Then after like a minute, then we can start sensing. So can you see? I've not gotten to the front that already sense. So okay, let me give it time. So that's it. So before we go, let me show you the sensor. Please focus on these two guys, these two variable resistors. If you are getting your PIR sensor for the first time, the variable resistor, this one and this one, are always facing upward. Okay, let me switch it off for now. So the variable resistor are always facing upward. So you need to tune it in order to sense the motion. So we call it calibration. So look at the way I've set this. I've set this in such a way to notice my movement or anybody's movement. So if you are getting your own for the first time, try and calibrate it in this manner. Look at the position, the tip, the flat part of the variable resistor. Look at where they are pointing. Let me check. So I'll be using my compass to point the variable resistors. This is the first variable resistor. Look at where the flat side is facing upward. One of these variable resistors is for time, the other one is for the sensitivity. So the time decide how long the signal should stay before cutting it off. The other one sense the distance, the area of the other one senses the area to cover. Variable resistor is pointing towards our right hand side. The other one is pointing upwards. So look at my resistor. Look at this IC. Look at where it is. So the variable resistor closer to this IC is facing up. The other one is facing side. Check it well. So look at it very well. If I get it with your PIR sensor for the first time, to always listen up, so you can try and adjust it to the best suitable time and sensitivity you want. But well, to my own use, I love it to be this way. Thank you. See you in the next episode.